Alright, so first stage of our video, we're talking about stepping on a Lego and what happens when, what happens when you actually step on the Lego. And we're explaining this to a 10-year-old. So the first thing would be that there are receptors in the body that are working throughout together that help you perform an action. So if something were to happen in the environment around you, your body's going to be able to react to it. So for instance, when you step on a Lego, there's a message that is sent to your brain from your foot or the area around that you are stepping on the Lego with, and it's sending that message up to your brain saying, hey, I'm on something that's uncomfortable, it's causing pain, and I need to make a movement. So your brain's going to end up telling your body to move your foot to stop the pain. That's pretty much the simplest way we could explain it to a 10-year-old who doesn't know a whole lot about how the brain works and different receptors are being sent to and from the brain.
Okay, so for the second part of this, we're going to be talking to someone who's our age. They have no background in motor control. We're still going to be using the example of stepping on a Lego. And so your body has different types of sensory receptors, and one of those receptors allows you to detect stimuli outside of the body. So if you were to step on a Lego, that sensory receptor would send a message up to your brain, and then that brain then interprets whatever that sensation is, which in this case it would be pain. And within the brain, there's a higher level sensory processing area, and that basically has to deal with decision making. So if you step on a Lego, your brain's going to interpret like, okay, take your foot off of the Lego. So after that message gets sent to the brain, it's going to travel back down to your foot through a motor neuron and allow you to take your foot off the Lego to remove that stimuli that's causing you pain.
So for the third part of our presentation, we're going to be explaining this process to a motor behavior professor. The first part has to do with the body having its own sensory receptors, and one type of these receptors is an exteroreceptor, which is located near the body's surface, and it helps detect stimuli that are outside of the body. Stepping on a Lego would cause pain, so a sensory receptor would travel up the afferent pathway from the pain towards the brain, where the primary sensory cortices will allow for awareness of the stimuli and where it originates from. Once the brain recognizes where the pain is coming from, the higher level sensory processing areas of the brain, such as the parietal, occipital, and temporal lobes, allow for higher levels of cognitive processing and make the transition from perception to action. Once this happens, the brain programs a movement to stop the pain by removing the foot away from the stimulus, which is the Lego. This happens via the brain sending a motor neuron down the efferent pathway towards the foot, which removes it from the stimuli, which is the Lego.